It's time for another basic 10-liner. I wrote for basic 10-liner contest 2024. In the other video I was talking about Dan the Digger, which actually won the whole competition. Hey! But in this one I'm going to talk about the other game, which I thought will actually take a better place than Dan the Digger, but yeah, probably there were reasons why it didn't. It took 7th place, and to be honest, I forgot to also upload the manual with code explanation, so I lost half a point because of that. If not that, the game actually would took 4th place, but who cares really. It's I still won the competition for another game, so I'm still super happy, and I was completely not expecting it. I will be really honest with you. Last year I submitted a game to the same competition called Roguelike 10, and it took 5th place, so I'm also super hyped. The competition was really high. But technically I think like this year I didn't do as much as the last year. I think that Roguelike 10 was just the most technically advanced game I was able to squeeze in 10 lines. But this year I thought, okay, let's try to do a more dynamic game, because all of my games, they were like turn-based. Also the Digger, the game that won, you can just drink tea or something and go back to the game. But so I wanted to do a dynamic game. So Incrediball, it's a game I did just to try to make something which is more dynamic. So I will start from the game first, and then probably I will go through the code. Of course, this is not the name of the game. That's the name of the game. I should use asterisk. Let's load the game. All right. And as always, for such games you need a joystick, because it's an action game. Okay, there's no sound. Actually, I wanted to put some sound, but I wasn't able. So that was something which was on my to-do list. But yeah, I didn't find a place in code. So the aim of the game is just to try to play as long as you can, and as you see, this ball bounces down, and when it hits the tile of the same color as the ball, and then actually nothing happens, but otherwise it will change the color and the brick will disappear. So the thing is that you don't want to fall into the pit, which can happen if you really you're not careful enough. And this game also has a progress, so later on the number of different tiles increases, which makes it a little bit harder, because you cannot just go faster right, you have to go with the good rhythm of this game and still try to score as much as you can, because you don't see the score now, which was technically hard to do, but the score will be visible at the end. Okay, now I have to do a very long jump. Okay, I made it. The other downside of this game is that actually this ball cannot go more right than some particular width. It's due to some limitation in Commodore 64 that you have to change one of the bits to actually move the sprite to the right side, and unfortunately I didn't have space in code to make this bit. So if I could have half a line even, then maybe it would be possible, but I'm not certain about it even. So that's why it might be a little bit unfair sometimes when you really want to move to the right part of the screen. So the recipe is just to try to stick more to the left side of the screen. It might be good just to keep in the center as well, but don't try to go too much right, because the limit is somewhere there. I think it's even invisible, so I think maybe that's why also the game scored not too much, which I can completely understand. Yeah, but that's the whole game. It's kind of slow now also. I wanted to make it more fun, but it's really hard to make scrolling actually in BASIC. I did some tricks with waiting for a raster, so that was kind of possible, but without few details here it would be much faster, but then there would be no game. So that was kind of trade-off between what I can do technically and how to make this game actually fun to play. So I guess it's kind of fun, maybe a little bit dull. This is just my also retrospection, because I thought this game is actually more fun when I did it. Now I just started to get a little bit bored. But yeah, as you see, the number of tiles, different colors increased, which makes this game harder. Sometimes it can be also a little bit hard and unfair, like here you see how much of the distance is between. I don't know if I'm going to make this jump. Let's try. Oh no, I didn't do it. And there was a score 34, and the game already starts again because there was no place for game over or whatever. So the game might be also a little bit unfair at times, which shouldn't happen too much. So let's show the code. I use the basic abbreviator, which is the kind of cartridge tool I wrote myself just to make abbreviations, because you have to put 80 lines, 80 columns into one line, and the hardest part is to make this abbreviation, because normally when you do list in for Commodore 64, like let's see for line number 1, then this go soup is actually not what fits in 80 lines. The abbreviation of go soup in this case is GOS, and then you can already, you can see, you can save these 2 characters. But the problem with that is that when I now go back, you see these 2 spaces. Yeah, the whole problem with this is that normally BASIC doesn't really pull all lines, it ignores the third line. That's why I use this basic abbreviator, just to automatically abbreviate all long functions into shorter versions. But then I can, as you see, I can fit stuff into lines, and then the next line is just starting from 2 lines after. So that's how I can achieve it, by just using this to automatically abbreviate and make game development much easier. Still maybe it looks a little bit hard at the first time what it does, but technically your eyes can get used to a little bit while you play it. You start develop with it. So there were a few tricks I used, so I'm just go shortly by them. One of them is the first one actually is the sprite of the ball, which I actually used to convert the same way as in the other game, Dan Digger. So the whole code is used here. You can see it over here on the bottom. And of course I didn't type it, I used the editor as well, which I wrote for this. So it can translate data, which I can just draw the ball, to sort of bytes, which are represented into PETSCII mode. So then I can just print them on the screen. And where are they print? When I run the game, I will show you. They're actually on the screen. You cannot see them, but this data is actually on the screen, and it's here. It's just hidden here. You see this monkey represents actually zeros. So let me change the background, maybe some more useful color like 0. So then you can see it was actually hidden under the grass, let's say. Yeah, the grass is just for this, to hide stuff. So in this grass, I've hidden the data for the sprite, and then I just didn't even need to relocate this data where the sprite bank is, because I just set memory to just point to this location. So then it automatically just can render this sprite here. As you see, the sprite is already corrupted. It's because I moved the screen up. If I move more up, you see the sprite changes, because actually it still points. Where is it actually? Oh yeah, it points here. Maybe you cannot see this that easily, but just by typing this random gibberish, I'm able to already change the data of the sprite. So that's one of the tricks I used, and the editor I will show you. The editor. Okay, so it's sprite. Which one is that? Sine table for jump. That's the other one. That's the sprite for jump. And that was actually the first working version of this game. Jump. I didn't know how to call it, so I thought that Incrediball is actually a fun name. So this is the ball actually. I just draw it, and then the code already runs, and it just translates each line. And there are 3 bytes per line. This is how the sprite works in Commodore 64. That this is translated, and then I can use this data just to put it into the code. Let's go back to the listing. Okay, so that was one of kind of tricks. Then I struggled with programmatically setting the bounds, so then I used sine tables. I will just show you this program at the end, just to generate some sine tables. So then there is no calculation here, which was kind of working slow and was also unreliable at times. So I then managed just to do index of, I think that's the sine table. It even looks like a sine table, because you see these values are going back, so it's probably a sine table that just does the whole movement of the ball. And I wanted to use some bouncing over there, so then it's just the half of the sine. It's just the cut, the upper top of the sinus, so the table can just be referenced, and the vertical position of the ball changes. One of the more tricks I use actually is just to save some memory, was also to look for common values. So there is W somewhere over here. I have some notes, but I cannot find the W right now. It's somewhere on the screen. You probably can see it already. And the value of it was 24. Actually, not 24, but 214 indeed. Oh yeah, so I read W here, but where is in the code, I don't know, because data is scattered as well, which means that there can be some piece of data here, like, oh yeah, there is some piece. Yes, that's the W. So I actually found that I can use W for more than one place. There is a limit somewhere, I think, for the vertical ball, where it checks when the ball should go the other direction or something like that. I don't remember exactly, but as you see, poke W, it's used here. So this is to put the ball on the screen, and this not the ball, but actually the land in this case. So I think I use it for the ball, I use it for the land, just to render the land, and that was really funny actually, to just see like, oh, this value was close to some other values I used. So then I said, okay, I can also, for this condition, I can also use just this value, and it's still, the code is still going to work. that's actually here. The W is over here, so this one actually indeed checks for the ball when the ball should bounce back. So I think the value was different, but it was still in the range that I can just use the same value. So that was a small trick, but it was really fun. And I see already that this is not the abbreviated version, because I started to notice some space here and said, oh, there is some space I could use. But this is of course an abbreviated, let's call it, version. In the abbreviated version you see 5 line number 4, number 5, there's only like 4 characters here and 1 character free here. So this one looks like, oh, this is so promising, 5 characters, but how much you can actually squeeze in this space? Nothing really. So I really didn't have more space. So that was really a challenging project, I have to say. Also, you've seen that the game starts immediately. It's because I didn't have space for game over and so on, and that's why there is a restore used here, so then the whole data can be read again. Otherwise the data couldn't be able to be read again from this scratch. So there are many small things like that, many small tweaks. I provided all of them and all the tricks and notes in the description, so you can find it online. And yeah, there is no much more, I think. So let me just show you this sine table. That's the last thing I used just to generate all this data. So it also translates to PETSCII, so then I can just display it somewhere on the screen and I can just direct it with peaks, for example. So that's the data which is generated, and the code was actually was it actually using sines? No, it wasn't. Oh, I know, I think I used sine table with some just online tool, something I found on Google, and then I just provided this data here by hand, and then the rest was just using the same kind of mechanism as the sprite generation code works, just to translate it to PETSCII. So that's all. Thanks for watching, and I hope we'll enjoy my other videos. That's a great competition. I encourage always everyone just to play a little bit with code, try to make something, and I hope we're going to see ourselves maybe in some other competitions next year, maybe for this basic Talani competition, or there are other kind of different similar competitions about writing games also in basic. I can do assembly, for example, but sometimes I found this basic competitions even more challenging, because you cannot just think of optimization in unlimited space. The space is really limited, and that makes the challenge really interesting. And there are also a few things I already know from previous competitions, so I got some experience, of course, but I still hope to find few new ways of thinking and how to do stuff more efficient. And also in case of this game where everything is dynamically working, how to make it working faster. It's really hard for basic, for Commodore 64 basic. Actually, it's really slow, really sluggish. So that's probably kind of another sort of challenges I'm going to look in the following years. So thanks for watching, and see you in the next video. Bye.